Well, welcome back to the Azure Podcast. This is episode number 511, being recorded on the 23rd of December, 2024. Today we have Kale and myself, just the two of us. Seems like everybody else is on the holiday break already, but we thought we'd get together and just share some of our thoughts on some of our favorite Azure topics that we're working on these days, and also get you caught up with some of the news. I believe we've got quite a few updates in December. Gail, I believe there's a lot of Kubernetes related updates. Is that what we're seeing this month?
Yeah, I don't have much today, but looks like you got a full plate there with the Kubernetes, so I'll let you go ahead and go through with that.
Okay, let's get started on that, and then we can get to your pet project that you're working on. So on AKS, Kubernetes Service, one of the first updates I want to cover is related to the network isolated mode of AKS clusters. It has been possible in the past to configure AKS to restrict the ingress. That means it only allow ingress to VNet join devices, to devices on your network. You can't access it from the internet. But in order to just boot AKS, you need to allow it egress because it has to download some of the images, the container images that are required just to start up all the basic pods in AKS cluster. And in order to further restrict that, you would have to set up an Azure firewall to limit where those egress endpoints are. Obviously, you don't want it to get images from anywhere in the internet. One of the trusted sources is the Microsoft Container Registry, which has all of the container images for AKS. So typically, you would allow access to that. But that still required you to set up Azure Firewall and do all the configuration. And there's always that concern that things are going to egress or leak. Current now, with this new network isolated mode, you don't have to set that up anymore. You don't need the Azure Firewall setup. Once you set up this mode, essentially, AKS can pull out its system images from your own ACR. Now, obviously, your ACR won't have any images to start with, but what happens is in the background, the ACR will pull it from MCR, from the Microsoft Container Registry, through the Azure Backbone, populate and seed the ACR, and now that ACR will always have the system images it needs to start up AKS. So this will limit the requirement for that egress and should be a lot more secure for AKS users. Talking about pulling of images, you know that, Kale, when you do a Docker pull, for example, it pulls all the layers of the container images from the repository. And those, if you have multiple images to pull, there you do one, you do the other, and it takes time. Sometimes you sit over there waiting for all these images to download, and you can imagine AKS, the multiple pods coming up and whatnot, and all of them have to be pulled or being updated. It could take a while. So now you can improve that performance by doing parallel pulls. So you can configure AKS to pull images in parallel from ACR or from any other container registry that supports parallel pulls. This should help speed up the time it takes to boot up ACR for AKS, for example. The third thing I'd like to talk about AKS is disaster recovery. Once you've set up your AKS cluster the way you like it in a region, you've done all the, let's say, the easy resiliency between the availability zones in a region and all that. So you're happy with that. In the worst case scenario, the whole region might go down. And then you're worried about how am I going to bring this up in another region. So now you can enable the Vault Tier backup for AKS, which will automatically take a snapshot of everything in AKS cluster and save it to Azure Backup. You configure that to replicate to the other region. And now in case there's a problem, you can simply go to the other region and restore your AKS cluster over there and have it up and running in a relatively short period of time. So I think this is a cool feature for those folks that are worried about regional outages. And then Azure, OpenAI and AI-related workloads are the big rage these days. And so now in AKS, if you use Windows nodes, you can have Windows GPUs for compute-sensitive workloads, and they can be managed completely in AKS. So this is an advantage. The Linux version is not yet available, but the Windows GPUs are available. And then Also on the security angle of AKS, one of the things, and I've actually done this before with pods in AKS on Kubernetes, there is something called the instance metadata service. It's in the node of every AKS cluster or Kubernetes cluster. And from a pod, you could typically reach out to it. It's a REST API. It's a well-known IP address on the node. You could reach out to it and get a lot of interesting information about the node. Now, the thing is that that information could be a security leak. And so you don't want to have pods having access to that kind of information because, a malicious actor might inject a bad container image in there and could find out a lot about your deployment. And so now the new feature in AKS allows you to block pod access to that Azure Instant Metadata Service. You can, of course, enable it if you want to, but by default, it will be only available to system pods, not to the user pods. So this I think is a good feature for all of those enterprise deployments of AKS. And then a few more along monitoring of AKS. Yes, they've always had the container insights. It's part of our Azure Monitor service that we have that allows you to monitor AKS and all of our other Azure services, for example. But in the past, it's been difficult to nail down or filter on specific logs within the Azure Monitor service, especially those coming from all of the containers in your AKS cluster. As you know, you have a lot of logs coming in. And now there's a new way to set up filters in when you do the searching. You could search, for example, logs by a specific container image or a specific label or things like that. So you could kind of specify all those logs, all those filters, I should say, when you're looking for specific log entries. Let's see. And Kale, have you used that GitHub Copilot for Azure? In the Azure portal, which lets you can say, I need help deploying to deploy a virtual machine or something like that.
I actually use it a lot if I want to ask it about like my resource providers, because sometimes you don't have them registered, and you'll say, hey, do I have this resource provider registered in my subscription or any of that stuff? Or what ones do I have registered? Like, because sometimes you have to dig through those menus to find those, so it's super makes that very fast.
Exactly, yeah. And so I'm glad to say that they're now extended that experience for AKS. So if you need any help with your AKS cluster, deploying it, securing it, doing some of the changes we just talked about, you can ask that of the GitHub Copilot for Azure, and it would try to give you an answer for that. So that's cool to see. Now, once you deploy your AKS cluster, you kind of have to get your applications out there. And typically that's been another headache. You got to figure out how I'm going to containerize all my apps, set up like a CI/CD work pipeline, etc. Well, guess what? Now in AKS, there's something called automated deployments for Azure. And with automated deployments, what that does, you go into AKS in the portal and you can connect it to your GitHub instance or your GitHub repo. It will create these pipelines, right, or GitHub actions in AKS, and those pipelines can be used to automatically push images. It'll containerize your code and push it back into your AKS clusters, and at the same time set up things like continuous integration, continuous deployment, so you could get that all configured over there. So that is a new feature out there.
So is that in that case, like your source, your repo, you have to have a Docker recipe like there, like an actual Docker file, and that's how it like finds it, or how's that work?
Yeah, I mean, if you typically if you have Docker files, right, it knows how to containerize. Now, there's two ways you can do it. You can say, I already have it containerized, and so I just need, to push it, yeah, or I need to containerize it and push it. So you have both options when you go through the portal. Yeah, there's both options available.
Nice.
Cool. Then let's go to the next one over here. Oh yeah, and this is I think just maybe one more here now. This is the application routing add-on, right? With the application routing add-on, that's what it does is it installs an Nginx ingress controller in your cluster. do route requests, right? So you can say this path goes to this controller, this pod, that path goes to that service or whatever in AKS. The problem with that approach is that when the moment you deploy this Nginx ingress controller, it opens up a public IP, right? And then because obviously it's expecting users to come in from the internet to come to your cluster, and you may not want that. You may not want the public IP. Maybe it's an internal application. So now you can enable that particular that particular option and say I only want it connected to internal IPs, not external IPs, and so it'll connect to an internal load balancer as opposed to the external one. So that's another feature.
That was a big problem I remember, even years back, because what would happen is enterprises, for somebody who wants to put something on the internet, it's okay, right? But for enterprises who want to kind of lock things down quite a bit or have a lot of policies around that, what they were doing was like basically they had to have their own custom ingress, controller and stuff because the problem is that other one was like kind of locked, right? It would just do this thing and then they had to
Correct.
react to it afterwards. Yeah. Yeah.
Yep.
Yeah.
Great. Yeah, so that's all the updates I had for AKS, and most of the updates that were in December were related to AKS. So, yeah, Kale, let's hear about your current project. It sounded like you were excited about some of the work you've been working on recently. So let's see what our listeners can get by you explaining it.
Yeah, sure. Well, I was chatting with Sajid, and we were talking about the end of the year chat here around, some topics. Yeah, we just had Ignite and things, so bunch of news coming out of there with all the kind of new services and things like that. But what I've been working on most recently, I'll say it's a hybrid because it definitely uses Azure a lot, but it's also more on the developer side about how we use these things, and that's around AI. We've talked quite a bit on podcasts about different AI services. We brought people on from machine learning way back, years ago, talking about our platform, and then as it's progressed to the current state with things like AI Foundry and Azure OpenAI and those kind of bits. Um, so basically, the stuff I've been like mostly working on around is the semantic kernel. And so for the listeners who don't know what that is, basically think about it kind of like a middleware, because what we have here now with these AI services is at the core we'll have models and we'll be using like Azure OpenAI or OpenAI to run those models, we'll build and run those models. And then on top of that we're going to build applications and those kind of things. But the connection between those two is as you can imagine, kind of technical, right, to make that work. And so the middleware that fits in there is from Microsoft is called Semantic Kernel. It's an open source project we've been building for many years, and yeah, back in the machine learning days, but now it's progressed to this point. And the framework started out as a .NET project, right? So C Sharp has been the first class client for it. And then over the years, things were added to it like Java, Python, and we're working on the TypeScript, JavaScript version as well. But the thing about it is what got me interested in it is, from a developer standpoint. So if I'm using the semantic kernel is going to make it easier for me to, feed in a connection string, similar to the way we did with databases in many years past. So we have this whole connection information thing about how we connect to it, what's the kind of security that we use. Do we use like an OAuth type thing, or do we use an API key, those kind of things, as well as the endpoints and all that kind of stuff that's involved in the models. But beyond that, then it's like, how do I actually use this thing if I want to create like a chat client, or if I want to create some sort of other interaction that I'm going to have where I'm going to pass, input prompts and get back this response from my model. So the kernel's the thing that's taking care of that. It sounds, I know the first time I heard about it, I heard that name semantic kernel. I was like, oh, kernel. It's like the Windows kernel thing, It's like, this must be really like a mystery machine or something, but it's actually pretty straightforward.
Yeah, I believe we've had that for a while, right, Kale? Semantic kernel, it's not new as such. We've had it for many years and used to be, I remember doing it in .NET quite a bit. Is it a .NET focused thing or is it available? Like, I think you said it's available in other languages and you're working on the TypeScript now.
Yep.
Explain that to our listeners. How does that work?
Yeah, so I mean, these are ports, and the idea is obviously when we do these ports of something like this is to keep the feature parity similar. We try to make it 100%, but obviously it's not always exactly 100% because this is a fast-moving place. With AI specifically, things change every day. And so typically what you'll see, what I've seen just historically, is just my opinion, is I see the things hit the .NET version first, and then they flow down from there. But rapidly that's starting to become they're happening faster, and maybe in the future we'll have some go the other way, right? They'll come from the other clients back in.
And the TypeScript work, is that for Node.js and Access for those kind of server applications? What's the use case there?
Yeah, so basically it's a pure JavaScript library. It's written in TypeScript that will allow you to basically interact and use semantic kernel the same way you did with C Sharp. C Sharp, typically we are creating, like a web API or console app or something like that we're going to use this library with because it's really just an SDK or a library. Same thing on the Node.js side. Now, obviously, there's differences between the languages, so those things are slightly implemented slightly differently. But at the end of the day, and they don't have the exact same method name, so between all these clients, but they're close, right? You'll see things like chat completion clients and things like that, like the really high-level APIs are similar so that people are less confused if they've used one of them and want to move to another one for some reason.
I remember there's the plugins is a big part of the semantic kernel. So are they going to keep that sort of concept in the JavaScript version? There'll be plugins that you could build that can encapsulate the logic for when you want to call out to, let's say, a service or a database.
Yeah, that's right. So that's one of the key kind of selling points for something like semantic kernel or these middlewares is if I want to bring my own data, right? So standing up a chat client that can, talk to the internet is one thing, but saying, hey, I want to bring my own data in a database and I don't necessarily want to put that on the internet, but I want to build a copilot or an experience on top of that. That's where this really shines because we can basically build these connectors, is what you said, like basically with these plugins that allow us to do enrichment, data plugins, all kinds of different things that feed into there. Those are specific terms that are more like for the semantic kernel, so they're like outside of the OpenAI scope. To it just receives an input prompt and sends back a response. Um, those they're slightly different. Like there's streaming ways to do that where it's real time. There's embeddings like for images and things. But at the end of the day, that's what it is. We give it some input, we get some output back out of it. That seems very basic, but it's nice to have that layer in between to allow us to have these high-level objects that we can work with, so that we can connect our clients, whether it be Teams or web or something like that. I think
Yeah, yeah, go
the one
ahead.
big
Yeah.
thing that's kind of progressed there that I'm super passionate around is multi-model support. And what that means is, for those our listeners who might not know, these models are things you've heard on the internet, like GPT-4 or 3.5 or something like that. You'll hear all these different models that are out there. Basically, the way it worked previously is you would essentially establish a connection and say, here's the model that I have deployed there, GPT-4, let's say, and then you interact with it, right? You send an input prompt, you get your response back. But now what's happening is we want to do things like specialize. You may hear about like, these specialized models that people are building. And what those are, in some cases are LLMs, in some cases are SLMs. Let's describe what that is. So LLMs are large language models. Think of that as like something you can't run on your machine. You need the cloud to do it. You need big GPUs and big clusters to run that. And the SLM is something that you could run on your phone or your laptop or something like that. So basically, if we could have multiple LLMs, right? We could have GPT-4, we could have Llama, we could have all these different ones that are up there. And they're kind of coded to do things like they're kind of specialized even themselves. Like this one does something really general. Maybe one of them does math really well. Maybe one of them does something else really well. So they have these different specialized models. And think about it like when the request comes in to say, hey, I have this client who's asking this question about X. Let's say it's asking about Sajit. Maybe I say, oh, ask the Sajit model, use the Sajit model when you see one of those things. And then he gets a response from that. And if you see Kale, then ask the Kale model for that, right? So basically in the semantic kernel, it's routing those requests and it's basically wiring that up so you can have multiple models, and that's called multi-model support.
So it's nice. It doesn't require you to use just OpenAI or Azure OpenAI. You could use any combination of these models could be Azure, but could be both of them, OpenAI, Azure, OpenAI, but at the same time, all these SLMs, and I know there's like thousands of them you can download from Hugging Face these days.
Yeah.
I know you mentioned Olama as well. Explain that to our listeners. I've used that, but I think it's a really interesting product out there.
Yeah, so along with this, the reason I kind of like stumbled into this even a little bit was because it was like, okay, well, if we have multi-model support, when is when you be able to run it like on our local machine? So if you can imagine, instead of just having LLMs that are very specialized, you have an SLM. So to give an example, like Pi 3 is one that Microsoft pioneered. There's a bunch of other small ones. There's even some small llama ones from like Facebook and stuff like that. There's different ones. So basically, those are very small, right? And so you could run that on your machine effectively, and then you don't have to even send a request up to Azure OpenAI or OpenAI to do that. That kind of inspired me and said, oh, that would be really cool if we could do that because as a developer, I don't necessarily need like a super computer, like big powerful model over here to do this because the workflows that I've seen so far, especially around copilots that we work on a lot, is there's a chat type interface where like I send an input prompt and I get a response back, and that has relatively low UI mechanics involved there. But now what we're seeing is like things like Teams client, where you have a rich client that wants to format things in like tables or charts even. We have these components that we can use. So if you start doing one of those projects, the first thing you have two things you got to do. First of all, you have to get the model giving you the right data back. And then once you get the data back, then you have to format it into this UI that you're going to display. So as a developer, I like things a little more deterministic because I want to be able to rapidly be able to do that UI. And so when I started working with that, I thought, okay, is there a way for me to run this local? And I found this tool called Olama. So what Olama does is allows you to simulate what's happening in OpenAI on your machine, right? So you can have an SLM. Now, obviously, it's not going to have all the features that like a big GPT model would have, but in most cases, we don't need that, right? As developers in this use case, and so you can fire up this local daemon that will run locally, and it looks like Docker actually. So you basically just tell it like which model you want to use, like one of these SLMs. It will go pull it if you don't have it, and then it sits there and runs and looks like it. Now, there's another piece that's on top of that that I found called Olama Azure, which one of our Microsoft colleagues actually built, open source as well. And what that does is makes it look like Azure OpenAI. So instead of it just being OpenAI, it looks identical to Azure OpenAI. So you could do this thing with a local SLM, build your application, have the front end working, and then just change the connection string basically to say, hey, here it is in Azure, and get the better responses from that.
Wow, I didn't know what that Azure OpenAI plugin for Olama or something like that. That's
Yeah.
that's very cool. Yeah, yeah. One of the things with the SLMs is that I've seen that they can benefit a lot from GPUs, right? Like I have a Surface Studio laptop which has an NVIDIA GPU, and yeah, when I run the Olama, you can configure it, you can tell it to use a GPU or not, and it's a big difference, right, in performance. Even though the Azure Surface Studio laptop is very powerful, using the GPU makes it, I think, maybe 100 times faster. It's a night and day. So I think if I would say that if anyone's going to be doing anything with Olama, make sure that you have one of these GPUs on your computer. Otherwise, doing testing, even a simple prompt could take 10, 15, 20 seconds to execute. And as a developer, you're going to get frustrated. You're like, okay, why it's taking too long? So that's something that I would recommend is that make sure that you have that GPU on your laptop.
Yeah, the other thing along with that, it's a good point, is the Olama website and their GitHub repo is actually pretty good at this. It'll tell you how many parameters and like how much memory roughly these models take. So obviously, if you have a machine with like 16 gig of RAM, don't pick one that has 48 gig of RAM like usage because you'll be paging and all kinds of other things will happen. It'll be really slow. So my advice is the same, like what Sajid saying, GPU, but also like try to pick the smallest one. Again, because remember, like this is not really guided towards accuracy and things like that from the model. It's more about, can I simulate that model a little bit like an emulator? Think of it like an emulator, so that I can do my work. So it does basic stuff that I need to do, and then all I'm going to do is change the connection string and get much richer info coming in there. So just keep that in mind.
Yeah, and I guess you could even take it a step further and actually use the SLMs in your application, right? If the SLM does everything that you wanted to do, and you do have access to the GPUs in Azure, you could. There's no reason why you can't use the SLM
Yeah.
for your application, right? I mean, I know GPUs are hard to find these days. There's a lot of shortage on them. One of the things that we talked about a couple of episodes ago was the serverless GPU option that's available in Azure Container Apps now. So that's one option where you just put your app in there. You just say you want the serverless GPU, and then you can trigger it to start on, let's say, an input queue or an input request, like a chat request or something like that. And then that's going to wake up, borrow the GPU for a few seconds, execute it, and come back. Generate your team's output or whatever it may be that has to be generated, and then it's all done.
Yeah. Yeah, even for the other stuff, it's pretty good for that. Like as far as building specialized models. So if you're into that side of the development house where you're actually building specialized models, that takes a lot of GPU to actually build them. But you can use this serverless model, so you don't have to have persistent compute there that you're wasting, but also paying for.
Yeah, and what I've been told is that it's easier to get those serverless GPU access to them. Like, if you want a dedicated GPU nowadays, you can't find it on Azure. It's difficult, but serverless GPUs, because they're shared by many different resources, it's easier to find them.
Yeah. The other thing along with this, these SLMs, is just real quick, is around these. You might hear the NPU discussion. So we have CPUs, GPUs, and now we have NPUs. CPU, obviously, everybody knows that's for running our operating system and doing our normal stuff in the computer. GPU was for graphics, but now it's being used for AI and a bunch of other things. But NPU is this neural processing unit, which is basically really fine-tuned to run some of these AI models. My experience has been there that they are kind of they're not general purpose. Like we talked about Olama here, where we could just bring a model and start running it there. That's less real today with those NPUs. It's a little harder to run those and take advantage of them directly. Now, one thing I wanted to point out, we'll put it in the show notes, is Microsoft has this project they're working on PySilica. So we had this Pi 3 and Pi 4 and those kind of things come out, these SLMs. But now we have this project called PySilica. Well, actually, it's been around for a while, but they're starting to open source this and talk about it now, the APIs and whatnot. So in January, those will open up in preview, and people can take advantage of, if you have one of these new Surface devices that has the NPUs in it, you can use that. Macs are similar. They have an NPU in them as well, and they have their own kind of SDK and work with that as well. Yeah.
Well, I'm really excited. Like, between the GPUs, CPUs, and NPUs, there's a whole lot of possibility there. You know, I'm really
Yeah, I
excited to
think,
see that.
well, when people were talking about, x64 versus ARM and how the battery savings and all that, and it's real, right? I mean, you can see that with these new instruction sets, like the battery usage is much better. But if you can further offload things like this, like to the NPU, that's really tailored to do that, you can even save more battery, right? So I'm excited about that. I think it's super cool for the future of devices.
Yeah, and the NPUs, like I said, they're tailored for inferencing, right? For running the model, not for creating them. The creating of the model,
That's
you
right.
still need the GPUs, but for certainly most of the people are going to be running the model, and that yeah, the NPUs are, I think, a perfect match.
Yeah. So I know it's not directly Azure. It's like an Azure service. I mean, we have a lot of Azure services around Azure AI, like the Open AI services and the content safety services and all that stuff. But this stuff's super important too for developers who are starting to build copilots and even direct AI applications. I think it's super relevant and it's super cool.
Yeah, no, thanks for calling out the semantic kernel. I myself have been using it recently and was pleasantly surprised how good and robust it is. It has, especially I was using the .NET version, and we built a complete chatbot with it with financial data on the back end. and it had everything that we needed and nothing more, right? It didn't feel like there was a whole lot to learn. It was just a few concepts you had to pick it up. I mean, essentially, the plugin concept is the main one. Once you got that figured out, then rest is just normal .NET code and not a whole lot of framework. So I was quite happy with the way they have designed that.
Nice. Yeah, we'll put some links out there to that stuff, but yeah, that's all I have on semantic kernel stuff.
Great. All right, let me spend just a few more minutes on some of the stuff that I found out which relates to accessing file shares from Windows services, right? From Azure services. You know that the most classic example has been a VM. Any VM needs to access a disk, and so you can use Azure Disks, which is the fundamental unit in Azure, to connect to a VM, and that allows the VM very fast access to files, but those files are locked into that VM. There's no way to access those files anywhere else. Okay, so if you have that sort of requirement where I just need to access files from the VM, and putting an operating system there is a good example of that, but just remember that everything that's on that disk is sort of locked in. So Azure Disks is sort of one of the initial things I wanted to bring up. If you needed something a little more flexible, you could use Azure NetApp, right? And NetApp files. So NetApp files is a way to set up a cluster, and this is our collaboration with NetApp. So you can set up a NetApp cluster in Azure, which gives you this very highly managed service to access your files, and also multiple users can access it, multiple services, machines can access those files at the same time. So it kind of manages all of that. If you want something a little less with a little less management overhead, then Azure Storage has a files service in it, right? Azure Storage has 4 essential services: blob, files, table, and queue. And so the files service in Azure is essentially a file share, which you can quickly enable and allows any other resources, especially non-VM resources, any PaaS resource like Azure App Service, container services, a container instance, whatever it may be, to connect to that file share very easily using the NFS or Samba protocols, right, which are the very popular ones there. Now, but the caveat is that you can either choose NFS or Samba. You can't have both at the same time. The NetApp service that I mentioned previously allows you to do them simultaneously. So it kind of there's a little more flexibility there, but of course there's a big cost and management overhead with NetApp as well. So Azure Files, is a very nice feature. I think that's one you should take a look at. The third one I want to talk about, the fourth one actually, is Azure Blob Storage. Surprisingly, Azure Blob Storage, we know it as a place where you can put blobs or large objects in a very efficient manner, very fast. But you can actually use it as a file share as well. Right? There's an option, say, exposes as an NFS file share, and it uses NFS 3.1, which is slightly older protocol, but it still is available, and you can mount it from any of these PaaS services. Now, in order to do that, you have to enable the hierarchical file system in the blob storage when you create it. That requires some Azure Data Lake component to be added on, but it's all part of the setup for Azure Blob Storage. Once you enable that, you'll be able to connect to it using either Samba or NFS. Accessing those. And then finally, the kind of more of a software solution that I've seen, and I've used this one as well, is Blobfuse. Blobfuse is an open source project that Microsoft started, which is a driver that you can run on Linux, and that driver can be configured to mount to an Azure Blobs container as if it's a file system, right? And it kind of creates, again, a hierarchy within the file system, within the container, to mimic the file system on Linux. So once you mount it, then you just access it as if it's a local disk without knowing any difference. I thought that the blob storage one, the use case for that is supposedly for if you do have a lot of reading, a lot of very intense reading, especially with machine learning or doing these risk calculations, things like that, where you're reading a lot of reference data. So for that, the blob storage one does make a lot of sense, and that's the scenario that I am actually working on. So I am going to be using the blob storage as a file share and trying to see if I can get more performance out of that. The best thing you want to do is when you choose your performance tier in blob storage is to choose the premium blob storage because that gives you all the SSD backed services and resources which are much faster. So that's kind of my finding over there. So that blob storage can, if you using it as a file share, there's a lot of advantages, performance being a good one. If you have more of a random read-write access, then the Azure Files that I mentioned earlier is a better option. So again, choose, depending on what your
But
use case is, you want to choose the right option.
yeah, and I would assume the experience in the portal might be slightly different than too, right? If you're using a file share endpoint like Azure Files versus blob storage with this flag ticked on, you're not going to get visibility to those files the same way, right? In the portal, it's going to look a little different. Is that right?
It does, yeah, because one uses the hierarchical file system, so that kind of looks different. The other one kind of makes the hierarchical file system in software, so it's slightly different approach. You'll still be able to access the files from anywhere. That is the one key thing. Both of them let you access them from multiple PaaS services. So let's say a good canonical example is if you have a lot of utilities that you want to share with all of your PaaS services. Maybe there are some debugging tools or a place to pull configurations from and things like that, right? So you put it in one place and everybody mounts to it and grabs it, right? So or writes to it if that's the case. That's one of the scenarios where this comes in, where you want a shared file system where everybody can access. And yeah, if in that case, both of them are good options. But if you need something that is more I/O intensive, then I certainly recommend the blob storage option versus the Azure Files. Right. Well, this has been a good catch up, Kale. Thanks for that insight into semantic kernel. And well, all our listeners, if we don't, we're not going to be. I don't think we're going to have an episode next week. So, well, happy holidays, and wish you all a happy New Year. We'll probably see you in the New Year.
Yep. See you next year.
Same to you, Kale, as well.